So those really make up some of the basics of set theory and how they're going to apply to probability experiments. Now, as we go through chapters 1.1, 1.2, and 1.3, we are going to have to deal with compound events a little bit more. And when we start getting into more complicated situations, it's going to be helpful for us to visualize things. Now, if we're going to visualize it, we are going to use what's called a Venn diagram. Now, you've likely heard of this in your lives at some point before, but essentially what it is we are going to draw a picture. So this box is going to represent the sample space, which is everything that could possibly happen in this experiment. Within that box, I'm going to put a blob to represent some event A. Now, event A might fill up the entire box, or it might just fill up a portion of the box. And that's fine. Either one of them will be fine for us. We just want to allow for the possibility that those options may occur. Now, in a moment, if there is no event A, we'll talk about how to write that out as well. Okay? And so we're going to talk about some basic combinations of events or sets. And you've likely heard of these before, but just in case, we'll throw them out here and try to illustrate them with a picture. Okay? So the first one we're going to talk about is intersection. So intersection is the set containing all outcomes common to two events or two other sets. Set containing all outcomes that are common. So in terms of a picture, if that's my sample space, I'm going to draw event A. I'm going to draw event B. And then I'll take a look and I'll say, okay, do A and B have any events that are common? And if I can see this visually, that's going to happen where the two blobs overlap. And so this region right in here is what we call the overlap. This is called the intersection. Now, mathematically, we write this as A, and we put this upside down U and B. So this upside down U is the intersection symbol. And so whenever we want to talk about that overlapping region, we will denote it by A intersect B. The other point to note here is that sometimes sets don't intersect. So sets may not intersect. Now in this case, you've got a picture that looks something like this and something like this. There's A and there's B. So there's no overlap. So we are going to give it a new symbol. We're going to say this equals a circle with a slash through it. So I'm going to try to write that a little bit better. This is called the empty set. It's the set with no elements. Okay. So if the sets are empty like this, we will call them exclusive events because they exclude each other. Okay. Another kind of combination that we're going to talk about is what's called a union of two sets. Now, a union of two sets is where you take A and B and you unite them or you join them. So you take every element that is common to both. So they are all elements common to both A and B. And the symbol that we're going to give it is A with an upside down U, B. So this upside down U is called a union symbol. So in a union, it's basically like saying, okay, in the case of an intersection, I've got all my toys in box A, you've got all your toys in box B. If we're looking to intersect them, we're saying, which toys do we both have in common? Oh, I've got a Superman and I've got a Wonder Woman and so do you. And so we would make a list of all the common toys. That would be the intersection. In the case of a union, I take all the toys from my box and you take all the toys from your box and we put them together. So I have a Superman and a Batman and a Wonder Woman, and you have a Spider-Man and an Iron Man, and you also have a Batman. So we put them all together and we make a new box of toys with all of the toys combined. But the one thing that we don't do is we don't double count. So we don't double count any elements. If you have a Batman toy and I have a Batman toy, we don't put them in together. We just take one of them and we get rid of it. And we essentially ignore the other one. Now, the final one that we're going to talk about here is what's called the complement. And this is all of the outcomes outside of our set. Now, some of you may have taken discrete math or a logic course in philosophy, and there are lots of different notations for complement. Now, according to the textbook that we are using, they use the following. So if this is set A, we want everything outside of set A, but contained within the sample space. And so the notation that we're going to use is A with the dash on it. And so that dash represents the complement. It represents everything outside of our set. Okay? And so these are the big combinations of things. Now, there are several properties and several basic exercises that you can do. I'll try to go through a quick little example here. Okay. My mistake. So as a quick little example, let's talk about set A containing a bunch of numbers. So we'll say 0, 1, 2, 3, 4, and we'll say set B is 3, 4, 5, 6. If I were to ask for A intersect B, I would be asking which numbers or which elements live in set A and in set B. Which ones are common to both? And just a quick scan shows that 3 and 4 are the only common elements. If I were to ask you for A union B would say combine all the numbers from set A and combine all the numbers from set B, but don't double count any. Well, if I combine them all, I end up with this set. Now, if I were to define this to be the sample space, let's say this is all the things that I want. If I were to ask you for, let's say, set B complement, that would be everything outside of B that lives within the sample space. So in this particular case, this would be 0, 1, and 2. So these kinds of things are pretty straightforward. There is one last thing I'm going to do. Sorry about adding this page here. The final thing that we're going to talk about are a bit of properties. Now, I'm not going to prove these, but they are fairly easy to believe, especially if you look at a picture. So, for instance, the order in which you unite or intersect two sets doesn't matter. So if I take all the toys in my box and I ask which are common with all the toys in your box, it doesn't matter if we talk about your toy box first or my toy box first. Same thing if we dump them all together, if we unite them. The order in which we intersect or unite is irrelevant. If we have a third friend who comes by and they have some toys, then we can start doing combinations with multiple sets. And then in that case, it doesn't really matter which order we combine them either. So if we want to combine friend 1 and 2 first and then 3, or vice versa, it won't make a difference. And so again, these types of properties come up a lot, and we will make use of that. They almost become second nature, things that you don't necessarily concern yourself with. There are some interesting ones that will pop up next class when we start solving problems with this. And here perhaps a picture will help a little bit, right? So if I've got two sets like this, let's call this A and let's call this B. If I say to you, what is the complement of everything of the intersection of these two sets? So here is the intersection. There's A intersect B. So if I want everything outside of those, outside of that region, it turns out, and you can take a little sketch and see this for yourself, it's going to be the union of everything outside of A with everything outside of B. And similarly, if I were to be interested in everything outside of the union of those two sets, so if I were to take the union of them and say, what makes that up? It would be the complement of A intersect with the complement of B. Now, this isn't necessarily obvious, so I recommend that you try to sketch it out and sketch them out individually and take a look to see if it makes sense in your brain. Okay? So that pretty much wraps up all of the major properties of sets that we are going to need to start talking about probability. So the questions that I'm going to post for you here are related to sets. Have a look at them. We'll be talking about some of them in class as well. You're going to be taking things a little bit further, and we will move on to probability from there.